So we were discussing about the type of the cloud seeding systems. The first one is the ground-based generator, where we use silver iodide to make the clouds. Then we have automated high output ground seeding system. Then we have cloud seeding aircraft, where aircraft mounted flares are used. These are released, these flares, you can see these are released into the atmosphere. Titan is basically a software. Titan means thunderstorm identification, tracking, analysis, and newscasting. It is a software which is developed for forecasting and analysis of thunderstorm in weather modification programs. Titan gives 10 derived parameters of the cloud, giving a scope to find latitude and longitude and cross-sectional view of the cloud at any instant. The cloud parameters given by the Titan are given as area, volume, mass, precipitation flux, vertical integrated liquid content, etc. You can see the first one is the area. By area we mean the area covered by the cloud. It is the value of horizontal spread of the cloud as observed by the radar. Then comes the volume. Volume is measured in cubic kilometer. It is the volume of the cloud. It is the value of the volume occupied by the cloud as observed by radar. Then mass in kilotons. Mass in kilotons, it is again the mass of the cloud. It is the value of the mass contained by the cloud as observed by radar. Then comes VIL. VIL is basically the abbreviation of vertical integrated liquid content of the cloud. It is measured in kilogram per meter square. It is the value of the vertical integration of liquid matter which is present in the cloud as observed by the radar. Next is P flux. P stands for precipitation. So it is the precipitation flux of the cloud which is measured in cubic meter per second. It is the value of the flux of the mass which is precipitation falling down from the cloud as observed by the radar. Next parameter is max Z. Z stands for reflection of the cloud. Maximum reflection of the cloud is represented by max Z. It is the value of the maximum reflection of the cloud as observed by the radar. Reflection depends on the type of the matter which is present in the cloud. Basically, if the matter present in the cloud is more, the reflection of the cloud will be more. Next parameter is the height, maximum height reflection of the cloud. Height of the maximum reflection of the cloud. It is the value of the height from which maximum reflection is coming from the cloud as observed by the radar. Next is the centroid. Centroid of the cloud is basically known as the center of gravity of the cloud. It is the height at which the total weight of the cloud is said to be concentrated as observed by the radar. Next parameter is the cloud base. Cloud base is the height of the bottom part of the cloud from the Earth's surface as observed by the radar. And the last one is the cloud top. Cloud top, again measured in kilometers, is the height of the topmost part of the cloud from the Earth's surface as observed by the radar. By using Titan software, we can compare various parameters of the seeded and unseeded clouds, which is known as the target and control method. In the target and control method, target means the seeded cloud and the control means the unseeded cloud. You can see this picture of the cloud on August 11, 2018. Here different parameters are shown, and here you can see the unseeded cloud and this one is the seeded cloud. So this is our target cloud and this is our cloud control cloud. Now we will discuss the advantages and disadvantages of the cloud seeding method. It contributes to augmenting freshwater resources to meet water demands, particularly in arid and semi-arid regions. It holds promise for regions facing water deficiencies. Its efficiency can be increased through research, experiments, and a better understanding of the precipitation and cloud system. Cloud seeding can contribute to increasing shallow underground storage water. It allows successful dissipation of fogs and low stratus clouds that can be an obstacle to aviation traffic at airports. It contributes to improve the productivity of rain-fed agricultural areas, either by increasing rainfall volumes or by sometimes controlling the spatial and temporal distribution of rainfall. Here are some disadvantages of artificial cloud seeding. The number one is the effectiveness of this technology in drought situation is very limited, primarily due to inappropriate climatic conditions during such periods. Positive benefits from a cloud seeding process for one group of a community may be accompanied by negative effects on other groups. For countries of limited areas or along national boundaries, cloud seeding could result in problems relating to possible negative effects that might occur in neighboring countries. Cooperation in such cases is therefore essential and may require issuance of legislation regulating the legal aspects of cloud seeding. Cloud seeding requires advanced and costly equipment as well as the recording, collection, and analysis of relevant information. The seeding process also required qualified professional staff and modern equipment. Thus, the benefits may ultimately not be sufficient to cover the cost. A cloud seeding program also will not produce effective results without accurate weather data or an inability to carry out the seeding process at the suitable time or place. Although planning of cloud seeding programs may be successfully and efficiently carried out, accurate and practical assessment of the results may be hindered by the lack of physical and statistical evidence. The assessment process also may require the use of modeling techniques.